Okay, we're supposed to graph this on a graphing calculator to see what the pattern is. But algebraically, right, a minus x squared, this is the meaning of, it's equivalent to minus 1 times by x squared, which is the same thing as, right, minus 1 times by x times by minus 1 times by x, which is minus 1 times minus 1, so minus 1 squared and x squared. And note that going straight from here to here is an exponential property, right? You can apply the power of 2 to negative 1 and x. That, of course, turns into positive 1. So we just get an x squared. So what I've done here, I've just shown that this and this is the same graph. It's the same equation. Okay? And same can be said about the next one. It's negative 1 to the power of 4 and x to the power of 4. But if you get negative 1 to the power of 4, you get positive 1, so x to the power of 4. Similarly, right, negative x to the power of 6 is going to be negative 1 to the power of 6 and x to the power of 6. So you get x to the power of 6. So they're all equal to each other, so of course we'll get the exact same graph. And the reason why they're the exact same graph, if you recall the parabola y equals x squared, it looks roughly like this, right? They are a mirror image. So this side is a mirror image on the y-axis to this side. So when you actually multiply inside the square, inside the power of 4, inside the power function, a negative like this, what it does is it reflects the graph on the y-axis. But what happens if you reflect the graph that's already symmetric on the y-axis, on the y-axis itself? Nothing happens. It just goes back to being itself. That's why they're all equal to each other. Okay.